See, the next important one here is an open circuit and short circuit test. Okay, I will tell you clearly. First of all, I will try to tell you efficiency number. Then I will tell you about OC and SC. Okay, what is a efficiency formula? What is the efficiency formula here? Efficiency is generally represented with meter. Okay, output by input into 100. Okay, so this is the efficiency formula. So how I can write the same formula? Output by output plus losses into 100. Okay, so just now we have discussed, right, what are the main parts of a transformer? Transformer core and transformer winding. Okay, so that means we have a two main parts. So two losses are exist in a transformer. One is in transformer core, that is we called as constant losses. One is in the transformer winding, that is we called as copper losses or variable losses. Okay, so this is a generalized formula of efficiency. Output by output plus copper losses plus constant losses. Okay, see, in this equation, to find these losses, we conduct the OC and SC test. Okay, to find the losses, OC and SC test we will conduct. Okay, so again, why we need two tests? Why we need OC and why we need SC? So to find these constant losses, we conduct OC test, and to find these copper losses, we conduct SC test. Okay, so this is the purpose and this is the efficiency number. Okay, efficiency output by input, and final equation is this one. To find constant losses, we are using OC. To find variable losses or copper losses, we are just conducting AC. Okay, so this is a diagram for open circuit test. See, look at here. First, what I am taking a transformer. Okay, I am taking a transformer, and what is this test here? Open circuit. If the name itself is saying open, so for that purpose, what I am doing? See, if you observe this side, I have connected the supply. Along with the supply, I have connected a ammeter, voltmeter, and wattmeter. Okay, so this is the primary side. So this side I am calling as primary side. So in the secondary side, if we observe here, open circuited. Simply, I didn't connect any element in the secondary side. So that's why we call it is a open circuit. Okay, that's why it is called as open circuit. Secondary side we have to keep kept open. Okay? So what is the procedure? Okay, what is the procedure? What is the procedure here? See, if you able to see here, this is a low voltage side, this is a high voltage side. That means in case of open circuit test, we will connect all the equipment to the low voltage side, and high voltage side we kept open. Okay, what is the procedure here? So this is a variant or auto transformer. Already you used or you did the experiment in the lab. That's why you have a little idea now. Okay, so by varying this auto transformer, I will apply the rated voltage to this low voltage side. What is the rated voltage? Means generally 110 volts by 220. So this is a transformer we have taken in lab. Okay, so 110 by 220 volts transformer if I am taking means the rated voltage on primary side 110. The rated voltage on secondary side is 220. So by varying this auto transformer, I will apply the rated voltage 110 volts this side. So at that time, what I do here, I will take all these meter values. Okay, ammeter, voltmeter, and wattmeter. Okay, so this wattmeter measures the power. So how much this wattmeter shows, that is this copper loss. So this is the constant loss or core loss value. So from the open circuit test, how we will get this loss? Clear? This is the open circuit test. So here I think we have written some procedure, everything. The same concept what I explained here. That is sufficient for that. Okay. Second one is AC test. Okay. Second one is AC test. So you can see the difference between the short circuit test and open circuit test. The major difference here is secondary side we did short circuit. Okay, secondary side we did short circuit. But in open circuit test, secondary side we did open. Open means we didn't connect anything. Short means simply we connected a wire. And same procedure. There is no difference here. But the difference here is now we change the transformer positions. That means primary side comes to HV and secondary side is going LV. So in short circuit test, we short circuited the LV side. We will connect all the equipments to the primary side. Okay, we will connect all the equipments to the primary side. So now what I do here again, varying the auto transformer, I apply the rated current. That is main difference between OC and SC. In case of open circuit test, I apply the rated voltage. Okay, but in case of short circuit test, we need to apply the rated current. Okay, so HV said rated current we will calculate by varying this auto transformer up to this ammeter shows rated current. We have to vary this one. So after this ammeter is showing the rated current, we have to fill. That means we have to take the voltmeter value, ammeter value, and this wattmeter value. Now this wattmeter in SC test showing the losses related to copper losses or losses which are occurring copper winding. Okay, so in this way from OC and SC test we will calculate losses. Okay, right. So next one is a regulation. So what is meant by regulation? So regulation means simple concept now. Again, what is meant by regulation here? See, this is a transformer I am taking. Okay, and this is a primary winding and this is a secondary. So okay, Nana. So this is a primary I am connecting the supply. See, in the secondary side, initially I didn't connect any load. Okay, initially I didn't connect any load, but primary side I have given the supply. So what happens here? Secondary side a voltage is produced. That is we call as E2. Now I am connecting some load. So now what happens here? Definitely a voltage is produced and this voltage is less than this one. Okay, secondary side there is a voltage produced when load is connected, but the voltage is less than this one. Now how much voltage it changes between these 2 points? That means how much voltage it changes from no load to full load. Okay, from no load to full load, how much voltage it changes? That is we call as regulation. Okay, so change in voltage from no load to full load, that is we call a regulation. So this is a E2 is a voltage under no load condition and V2 is a voltage under full load condition. So how much voltage is changed from no load to full load, that is we call as regulation. I think the next and last topic is losses. So we have mainly, we have discussed about only 2 losses that are losses which are occur in the core and the losses which are occur in the winding, right? But again in the core loss, see, in a transformer there exist 2 losses. One means the losses which are occur in the core we call as core losses. So core means it's a rectangular box. That rectangular box we call as core. Okay. Second one, the losses which are occur in the winding. So winding means here the copper wire or these conductors we call as wiring. Okay, so these are the main losses. But again in the core losses we have 2 types. First one is hysteresis loss and second one is eddy current loss. Okay, what is meant by hysteresis and what is meant by eddy current, I try to tell you. Okay, so what is meant by hysteresis loss here? Okay, again, if we go through the basics now, what is the type of flux I am giving? Alternating flux. So alternating flux means, what is meant by alternating? At some instant the flux is positive, at another instant flux is negative. Okay, positive means suppose if I take this direction, what is meant by negative? So this direction. So every half cycle, suppose if the flux is going this direction, in the negative half cycle, what does it have to do? It has to go in this direction. So for every half cycle, the flux direction changes. Okay, the flux direction changes, but the changes doesn't happen immediately. The changes doesn't happen immediately in the transformer. So it takes some time. In that time, what happens? Some amount of energy is utilizes to change the direction. Okay, to change the direction. So that energy we call as hysteresis loss. That means that is unnecessary, right? See, when the flux changes, the flux direction is also has to be changed. But to change this direction, it takes some amount of energy. That is we call as hysteresis loss. Okay, so second one is eddy current loss. So what is meant by eddy current here? And again, suppose if I am taking the transformer core. So the transformer we are taking is a solid conductor. So solid conductor means it has some width and some length. Okay, so when current is flowing through this transformer core, what happens here? Generally, the current is flows through only winding. Generally, the current is flows through only winding. But what happens? Some amount of the current is flowing through the transformer core also. Okay, this is also unnecessarily it is flowing. Okay, so some amount of current is flowing through the transformer core. What happens here? Due to that current, some amount of power is wasted. Why? Because transformer core have some resistance. Okay. See, I am saying here generally, Nana. So, if you need to choose one day, it will be tough. But I am just generally explaining you. Okay. Some amount of the current is flowing through the transformer core. Hence, this produces eddy current losses. So that current produces eddy current losses. Clear? Right. And next one are the copper losses. So copper losses means the losses which are occurring in the primary winding and secondary winding. So these are the copper losses. The losses which are occurring in the winding. So the winding have some resistance. Due to this resistance, some amount of the loss is wasted. And similarly, the secondary winding also, there due to that winding, some amount of the loss is wasted. So these are the broadly classification of total losses. Okay. So core losses, again core losses two types, hysteresis and eddy current. And second one is copper losses. In the copper losses also primary copper loss, secondary copper loss. Clear? So this is